Within the history of SETI, there has always been the question of whether we'd actually be able to identify an alien signal of some type, whatever that may be, even with a simple radio signal. This is a problem on multiple counts. After all, even with just a radio signal that repeats, how do you know what an alien's timescale is for repeating it? We may worry about 2 or 3 years, but they may work on scales of 100 or 200 years, or thousands for that matter. So if a signal repeats, and it only does so every 1,000 years, it's not likely we'd ever know it's there, and if we did, it would appear to be as a one-off and not pass the criteria used to determine if signals are interesting. This is always a possibility in regards to transient signals we've picked up that never repeated, such as the WOW signal. If it was of alien origin, does it really do us much good if it only repeats every 349.2 years or whatever arbitrary number you want to toss out? Not really, at least within most people's lifetimes, especially since we can't monitor the area it came from 24/7. And for that matter, all observations of the area of the WOW signal add up to very little time since 1977, a month or so over 4 decades. So it seems likely that without knowing the period it repeats at, that we'd ever just happen to pick it up again, without constant monitoring over very long periods of time. This problem is compounded by an even bigger problem. The electromagnetic spectrum can be broken down into billions of channels, slices of the radio spectrum, so to speak, where you tune the dial to a specific frequency and look for a narrowband technological station. This is hard enough with a weak signal from a radio station just a few miles from you, and even harder when dealing with light years of space, where signals get weaker as they travel through space. In dealing with that, the approach within SETI of late has tended toward targeted searches. You look right at a star system and you see if you pick anything up. So far, nothing has been found, but this is probably how aliens would see us if they have any hope of doing so. Our signals in space get very weak very rapidly with distance. They'd need an enormous radio telescope and know to look right at us to find us. And they'd need to be close, given that we've only emitted radio for about a century. But who knows what technologies aliens have? But that also assumes that they'd know or remember what to look for from a primitive civilization. They may view radio as quaint, or more likely use it in a manner differently than we currently do. But the argument can be made that they'd probably always use radio in some form or another indefinitely, even if they are highly advanced. Some make the case that they wouldn't, and that there's some other possibility for communications, perhaps faster than light, that they might use and just leave radio for nature. But the problem there is that useful is useful. After all, fire was harnessed here on Earth by our hominid predecessors, yet we still use fire hundreds of thousands of years later. Indeed, there are more artificial fires burning on Earth now than there ever has been, whether it's in your fireplace, or the pilot lights of your heater or stove, or the plant generating at least part of your electricity, or the constant combustion that powers internal combustion car engines. But there's a bigger one, radar. It's hard to envision replacing radar when it works on large scales very well. Using the former Arecibo telescope, huge pulses of radar allowed for the mapping of asteroids. You could use other technology to do that, perhaps unforeseen technologies, but if you could do that, it would probably cost enormous amounts of energy in comparison to just using the electromagnetic spectrum. And radar is essentially the most powerful signals we can produce economically, far stronger than normal communications. So it seems that it might be like fire and never go obsolete. But then again, if anyone ever picked up the radar pulses we use to map asteroids, they'd see it once and it will never repeat, because we never repeated those signals. So that brings up transience in SETI. You're taking a chance and looking for a brief time to see if continuous radio signals are being emanated from a star system. Granted, modern SETI can cover billions of channels at once, but it can't monitor everything 24/7. There are initiatives afoot to change that and provide all-sky 24/7 monitoring, but we're not quite there yet for the most part. But even when we get there, we may not readily pick anything up. And that could just as easily be due to not looking in the right way, as opposed to us being alone. Indeed, the universe could teem with alien signals, but we just don't know what to look for in identifying them. All we really can do is work from what we do technologically and know, and look for the same thing out there. What future technologies that may eventually exist are difficult to foresee, and as a result, we really don't know what to look for in that regard. But there is one kind of technology that's coming onto our radar, so to speak, that we might be able to look for. This stems from a recent paper by Michael Hippke, link in the description below, that points out that all we've really looked for so far are classical communications, the type we currently use in radio. You're looking essentially for a strong enough signal above the background of a type we as humans might produce. But our technology changes and grows, so while we may use radio indefinitely, how we use radio may change. After all, a campfire is a very different thing from a gasoline engine, even though both make use of combustion. This has happened before. You could draw a comparison between communications inside of a transatlantic cable to radio signals sent through the air decades later. While not the same thing, they could convey the same thing, such as Morse code signals. This in turn led to voices on radio stations, and then broadcast television. And then we've since moved back in the direction of cables, which is partly how I'm talking to you now. But certain things were never abandoned, such as the copper wire. Rather, they just continue to serve their best purpose, along with the new technologies such as satellites and fiber optics, and it all integrates in different ways across time. All of this starts with someone asking the question, is there a better way to do this? Sometimes the answer is yes, and sometimes the answer is no, or some middle ground in between. But ultimately, that's how our current technology developed. We use past and the current and think of different ways to harness it all, because in the end, these materials and properties of the universe, such as copper and fire, remain useful because they are inherent to our universe and what it allows. You can apply this thinking to many things. Do we still use leather? Yes, even though it's beyond ancient. Do we still use wool? Yes. Do we still use stone? Yes, but most no longer make knives from it. But you can certainly find people that still make them. But we will still face a building with polished granite or marble, which are ancient practices. We still use wood extensively all over the world for many purposes, yet using wood is beyond ancient. Even chimpanzees have been observed to use it. So the materials of your environment never really go obsolete per se, rather they might fall out of a certain use, but their properties may bring them back into use in the future. The materials of the universe are useful, so if they fit the bill for what you want to use them for, then there you go. Same with the electromagnetic spectrum. If it does the job with the least expenditure of energy, then there you have it. But can it be improved upon? The answer here is very likely yes. The paper goes on to detail the idea of quantum communications as opposed to classical communications. This concept has a major advantage, especially in our world of today: security. It's no secret in our modern world that classical communications as we do them currently are open for hacking. It happens all the time, leading cybersecurity into areas that don't necessarily involve straightforward ones and zeros, but rather quantum superpositions to both encrypt data and also tell whether anyone's seen that data. This is already in practice to a degree, but it promises greater security in the future as the technology develops. So here's the question. If we're set to eventually use this technology for communications, why wouldn't alien civilizations more advanced than we are do the same? And herein is the problem. If they do, we'd very likely never detect it with all the SETI searches we've done to date. In other words, we're blind to this one. And it may be that if we can devise a way to search for these kinds of signals, then all of a sudden an entire universe of communication could open up that just a few years ago, few could have predicted would exist. This is an old problem within SETI, indeed amongst the first it came up against. When the concept of looking for alien radio signals was first advanced by Cocconi and Morrison, they chose to look in radio because radio communications are cheap and simple when compared to other areas of the spectrum. That status quo lasted about a year due to the development of the laser, which promised a much tighter beam and data rate, and thus was born the concept of optical laser communications. This is looked for in SETI in addition to radio, but so far to no avail. The point is, a potentially better form of communication was developed about a year after radio communications were first advanced as SETI targets. But that doesn't mean aliens ever stopped using radio, nor does it mean they stopped using laser for some unknown better technology. Just that the uses of these technologies based on fundamental attributes of nature by civilizations tends to change rather than go obsolete. So say alien civilizations eventually go to a quantum communications route, and that's why we haven't detected them yet. This paper gives 4 reasons why aliens, and indeed eventually us, might use quantum communications over classical. The first is simply to keep out the riffraff of very primitive technological civilizations. They won't understand your signal and may not even recognize it as unnatural until they get to a certain level of development and realize that nature does not produce signals like this. We are just now reaching that point. In the past, a number of potential methods of communications have been proposed that might make for something so advanced that we wouldn't recognize it. Examples of this are neutrinos, which in principle can be used for communication, but in practice are inferior to photons. Same with neutron beam communications. Photons get the job done cheaper. People often suggest that aliens might use spooky action at a distance for instantaneous communications, but no one has so far worked out a way this can happen, at least directly, and in violation of causality, given that the transfer of information in this way seems to be strictly prohibited by nature itself. But quantum communications do promise to be able to use a form of quantum entanglement for very secure encryption, which is being pursued by several groups on Earth right now, but that doesn't violate the speed of light limit. But with quantum communications, the paper makes a good case that this might really be better. The second point made as to why quantum communications might be employed by alien civilizations is that quantum computing offers known advantages over normal computation, and this is also something being pursued today. It may likewise be possible to use it in communications, which brings up point 3, which is the improved security. Point 4 is that quantum communication might allow for increased information transfer over classical communications. So there may be something here, and it may be so profound that it might solve the question of the Great Silence. And the good news is, we may now be able to detect some of the envisioned forms of quantum communication, and that some of them would bear attributes that even if we didn't understand them, they would still appear unambiguously unnatural. You might know it was aliens, but it might take you anywhere from now until forever to figure out what they were saying. But classical radio also suffers this problem. There's no guarantee you can decipher a signal there, and while there are ways in radio astronomy to determine if a signal is of technological origin, it seems a strong possibility that alien quantum communications might offer something even better, and thus a potentially better method of detection. And indeed, some searching for it, at least at a rudimentary level, is within the realm of our current technology. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently enjoying my holiday season gifts. Anna gave me a healthy kale salad with water dressing. The possum recycled a fruitcake that expired in 1992. The cats sent an ultimatum for more cat treats, and the LeBaron sent a lovely beef log with a processed cheese package. The holidays, made all the better by a picture-perfect successful launch of the James Webb Space Telescope. Its solar panels then deployed, and it successfully fired its thrusters. It's now well on its way to L2 as planned. It's happening, everyone, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.